Welcome to our exploration of selective reabsorption, one of the most critical processes in the nephron. This step is all about saving essential substances like glucose, amino acids, and water from the filtrate and returning them to the bloodstream. Let's dive into how this works and why it's so important. After filtration in Bowman's capsule, the filtrate contains water and small molecules like glucose, amino acids, and ions. However, these aren't waste products. They're valuable to the body. Selective reabsorption is the process where the nephron recovers these substances and returns them to the bloodstream through the peritubular capillaries. Reabsorption often involves active transport where substances are moved against their concentration gradient using energy. For example, glucose is actively transported out of the filtrate by specialized cotransporters, similar to those in the small intestine. The proximal convoluted tubule, or PCT, is the first stop for reabsorption. Roughly 70% of the filtrate's volume is reabsorbed here. This includes glucose, amino acids, and sodium, which are pulled back into the bloodstream. Water follows naturally due to osmosis, making this region critical for both solute and water reabsorption. To put this into perspective, about 5% of your blood volume is filtered into the nephron every minute. Without the PCT, we'd lose far too much water and nutrients. This makes the PCT essential for recovering most of the filtrate. Here's a question for you. Which of the following best describes what happens in the PCT? A. Only waste products are reabsorbed. B. Glucose is secreted into the tubule. C. 70% of filtrate volume is reabsorbed, including water and glucose. D. The filtrate becomes more concentrated as only water is reabsorbed. Pause here to think about your answer. The correct answer is C. 70% of filtrate volume is reabsorbed, including water and glucose. Both solutes and water are recovered in this region, ensuring the body retains essential substances. Further along the nephron, selective reabsorption also occurs in the distal convoluted tubule, or DCT. Unlike the PCT, reabsorption here is more regulated. Hormones like aldosterone and antidiuretic hormone, ADH, fine-tune how much sodium and water are reabsorbed, depending on the body's needs. For example, aldosterone increases sodium reabsorption, while ADH promotes water reabsorption. This helps the body adjust urine concentration and maintain fluid balance. Let's focus on glucose. In normal individuals, glucose is filtered into the tubule at concentrations identical to those in the blood. However, 100% of the filtered glucose is actively reabsorbed by epithelial cells in the PCT and returned to the bloodstream. This prevents glucose, an essential energy source, from being lost in the urine. If blood glucose levels rise too high, as in diabetes, the kidney's reabsorption capacity can be overwhelmed. This results in glucose spilling into the urine, a condition called glycosuria. To recap, selective reabsorption occurs in the nephron to recover essential substances like glucose, amino acids, sodium, and water. Most reabsorption happens in the PCT, which reabsorbs around 70% of filtrate. In the DCT, reabsorption is regulated by hormones like aldosterone and ADH. Understanding selective reabsorption is key to appreciating how your kidneys maintain balance and prevent nutrient loss. Ready to test your knowledge of selective reabsorption? Visit KOTCME for interactive quizzes and detailed resources to master kidney physiology. Thanks for watching, and we'll see you next time.